So I'm the Environmental Technology Manager at CSIR, and what I'm going to share today is a little bit of a few examples of how we use innovation in the environmental space to drive cost-effective solutions. So at CSIR, we've got quite a large team focusing on environmental research. We've got about 60 scientists, engineers, chemists, all looking at innovating in the space. And we've been doing it for quite a while. But what we've seen is in the recent times, we've had to take a different approach to really drive innovation. And I'm going to share some of those ideas with you today. So just let me start. For those of you who are not familiar, I'll do this very quickly. CSIR's an integrated petrochemical company. We start with natural gas and coal as our feedstocks, and we make a whole range of products. So typically CSIR is associated with petrol and diesel and jet fuel, but in actual fact, we make a wide range of chemicals, waxes, lubricants, explosives, fertilizers, a whole range of products. So the obvious question is then, if you're making so many products, why do you still have to make waste, right? And the answer is that we start from what's quite a dirty feedstock, which is coal, right? And if you start with coal as your feedstock, you're immediately on the back foot, because coal gives you more than just the carbon, which is what you want. Coal starts with only about 40 to 45% carbon, but in coal you have a whole lot of ash that you have to deal with, inert material, metals. Coal is a complex hydrocarbon, so to get from coal to this clean fuel at the end, there's a lot of work that has to be done, and in that process a lot of waste streams are generated. So we use a lot of catalytic conversions, and even when we use biocatalysts, so bioprocesses as catalysts, which we use in our wastewater treatment processes, we still generate a lot of waste because those bugs grow and multiply and you still have to deal with that. So waste is inevitable, and I guess what I'm saying is you have to find smart ways of dealing with the waste streams. The real challenge with dealing with waste is this host of environmental legislation that's hitting us in the near term. So in the very short time frame, 0 to 3 years, we're being faced with carbon legislation, changes to the Air Quality Act, the National Environmental Management Act, the Water Act, or new water regulations that are coming in that's driving efficiency. And on top of that, you have the new Waste Act that you have to comply with. So balancing all these different environmental drivers is quite a tricky process, especially when they are so intimately interlinked, where sometimes when complying to an air emission standard drives you to generate a new waste product, or complying to a waste standard causes a new air emission or increases your water usage. So balancing all these environmental regulations, and this is not exhaustive, the list is a lot more than that. Balancing it all and delivering in a short time frame is quite difficult. So at CSIR, what we normally do, and anyone who's worked in the waste area is familiar with this waste hierarchy, where disposal is the bottom of or the last option that one would want to consider. That is the approach that we follow. Now, I'm sure every company that deals with waste says we follow this approach. We start with avoidance, minimization, and disposal is the last option. But do we really follow that approach? And to be quite honest, the easy way is still landfilling of waste. And this is typically how we deal with our waste. So this is an example in Secunda of a fine ash dam. And this is an old picture, but this is what we would call a black products dam. So this is where one would typically dispose of tar, heavy bituminous products. So that is the easy way, because you dig a hole and you put it in the ground. But is this sustainable? So this is a recent picture, and this is taken last month, where we're constructing a new fine ash dam to dispose of ash. And as the waste legislation has become stricter, where it seeks to drive waste streams away from landfill, it forces you to think about how you're going to get these streams out of the landfills. And even for streams that are allowed to go into landfill, the liner requirements and just the monitoring and all the requirements with managing this waste in a landfill are exceptionally expensive. This new fine ash dam that's going to last us for about 15 years in Secunda is going to cost almost 6 billion rand. So it's not a cheap exercise. And I would say probably 20-30% of that cost just comes from the line that we have to put in. And that's not all. So this is another photo of that black products dam that I showed earlier. And we've now rehabilitated that dam to look like this. And the rehabilitation started in 2012 and it will finish this year. So it's taken us 5 years to do that rehabilitation, and it's cost $400 million. So rehabilitation of a black products dam is not easy, it's not cheap, and it's very expensive. This is an ash dam in Sasolburg that's been rehabilitated. So we've kept it, we've had to revegetate it and manage it. And the costs don't stop there. So the costs, I mean, you still have to monitor this thing going forward. You still have to manage any runoff or leachate that comes from these dams. So while landfilling may look like an easy way out and a nice solution, it's not necessarily the cheapest way of dealing with waste. So what's the alternative? And for us, we currently look at incineration as an alternative. And why we like incineration, it's also a relatively easy solution to manage. You can mix all your waste, you can throw it into one place and burn it. And especially when you're a fuel company where you've got gas or a liquid hydrocarbon stream that you can burn together with the waste, incinerators are relatively easier to manage. The problem with incineration is with the new air quality regs, so this is what an old incinerator would look like. This is now what the air quality section on the back end would look like. So the costs of incineration have ballooned tremendously, and complying to these air quality standards would almost make it very difficult to justify incineration. The other problem with incineration is that it's not a solution that makes the waste go away. So with all this air cleanup, you still generate a wastewater stream, you still generate a final waste stream that you have to deal with. So there's still a legacy that comes with dealing with waste that goes to an incinerator. And then lastly, it's got a large CO2 footprint. So you basically taking this waste. Yes, you can put a waste heat boiler at some point and recover some energy, but in essence, what you're trying to do is not a very efficient way of getting rid of waste. But in any event, I mean, Sasol had 5 years ago looked at all the options, and again, as I said, we looked at the waste hierarchy, we looked at everything, and somehow we landed on landfill and incineration as the preferred way to go. And then what happened? Because if that was what we were going to do going forward, I wouldn't be here talking today, right? So really what happened was, this was in 2014 when we submitted our postponement applications for our current incinerators, and in those applications, we outlined the fact that we would be building new incinerators, we would be building new landfills. And this was what the oil price was doing around 2014. So we were enjoying a relative comfort of a high oil price, things were looking good, and then the oil price dropped to $30 a barrel. And that forced an immediate rethink of our plans. And I actually saw it as quite a good opportunity, because I'm not sure we were giving the waste hierarchy the full attention that it deserved, because it was too easy to default to the easy options, which are big capital spends and relatively easier to operate. So what I'm going to share with you now is just two examples of how we used innovation in the space and the climate that it created to enable innovation. So what I've observed at Sasol is, for us to create a climate for innovation, you need three critical things. So the first thing is the right amount of pressure. If you don't have the right amount of pressure placed on the team, it's very easy for us to dismiss ideas, to meander along. Every couple of months you come up with a new idea, you look at it, you think about it, you throw it out. But a high pressure environment creates immediate focus. Coupled with a high pressure environment, if you have management support at the highest level, it also allows you to drive these ideas forward. The second thing that you need are clear and well articulated goals. So having a goal stated like we want something better than incineration, or we want something better than landfill, that's not a clear goal. So it doesn't set a time frame, it doesn't set an economic target for the team to chase. So um, the waste hierarchy, it looks great, but it says, show us that you've considered everything. If you can tick those boxes and you land on, we need a new incinerator, then you've tried your best. Sorry, we have to do that. But having a clear goal, saying by this date you need this at this cost, that drives the right behavior. And then lastly, something that we were lacking was these multi-skilled, diverse teams. So we've got a waste research group, and what we've said is, you guys are the waste research group. It's your job to find new ideas for our waste streams. And that's not the way to do it, which we found when we had real pressure. So what you really want to do is bring in people from all parts of the organization to help you innovate in this space. You can't rely on just a waste group, and a lot of companies have a waste group or an environmental group, and people look at them to drive the innovation in that space. So I'll share one example where in Sasolburg we use caustic to clean a gas stream that goes into one of our polymer processes, and we use that caustic to scrub out the CO2 and any organics that may be dissolved in that stream. And what we were doing is that at the end you generate this what we call spent caustic, which was 80% water, a little bit of organics, and then the CO2 that had gone into the stream. And the current way it was being disposed of in Sasolburg was to put it in an incinerator. So you can imagine that if you're incinerating something with 80% water, it's going to take a hell of a lot of energy to do that. And what we were actually doing was then taking one of our product methanol streams to provide that energy and use that to burn essentially water. And then we looked at the retrofit costs for this incinerator, because the new air quality standards are quite strict. And what we said was, to meet these new air quality standards on the back end of the incinerator would cost almost R500 million. So the team, our postponements on these incinerators run out next year, had to come up very quickly with a solution to develop an alternative to incineration. And the last thing is this incinerator that we put this water stream in created a large wastewater stream. And actually that ended up being the driver, because the salts in this wastewater stream are currently discharged into the Vaal River with our other waste effluents. And as you know, there's a lot of pressure on removing salts or saline effluents from that. So that actually set the critical time frame for this. So for this example, we had all three key elements of what we needed. So we had the management support at the highest level. This was from the MD of the site saying, you guys need to give me a solution to deal with this waste stream. And we had a clear date by mid-2018 for this to be developed. We knew that the alternative was R500 million. And because we had this pressure and management support, that enabled us to create this multi-skilled, diverse team. So it allowed us to then pull people from all parts of the organization. We could pull operations people, engineers, scientists, chemists from all parts of the organization. And I mean, we even had a zoologist on this particular team working with us. So what we did was we created a task team, and we ran it like a proper task team with dedicated resources focusing only on this problem. Started with brainstorming of ideas. And initially, we all sat down in a room for a couple of days, came up with 27 ideas initially, and the process was to then assign this to people, the best people in the room, to work these ideas, and work them to a point where you could either kill them or progress them. And how we did it was with daily check-ins, so that I find is quite effective, especially when you've got senior management support, because then if you experience any bottlenecks, if there's a lab analysis that can't be done, or you need to procure something quickly, having that senior support can help you bypass a lot of the hurdles that typical organizations have. And then having everyone around the table discussing this every morning allows you to quickly eliminate ideas, and it stimulates quite a robust discussion. The other thing that this robust discussion does is it stimulates new ideas. So it forces you to think outside the box, because you'll be sitting there having a mechanical engineer asking you, well, why can't you do this? And your immediate reaction is, but that's a crazy idea, you never do it. But we never allowed ideas to just be killed without being properly documented. So you needed a proper reason for throwing an idea out. So either it didn't meet the economic criteria, it didn't meet the technical feasibility criteria, or it didn't meet the time frame. And if the idea didn't fit in there, then it got kicked out. And this process, I mean, it's not smooth sailing. So in this particular example, I mean, we worked on this for almost 2 months with no success. And we'd been working ideas through the process. So there are days when it does look particularly dark, and it looks like, well, guys, it looks like the incinerator is the only way to go, and if you've got to do it, you've got to do it. But eventually, and in this particular example, what happened was, we had, luckily, although this problem was based in Sasolburg, in our task team we had people from our Secunda operations in there. And one day the one guy came in and he said, hey, in Secunda, we also generate a lot of effluents, and our effluents are highly acidic. So before we dispose of these effluents, we need to neutralize this effluent. And the stream that you are considering a waste and a problem is a highly basic stream. So can we not use this highly basic stream to first neutralize our waste and or wastewater and put it in one of our bioprocesses in Secunda? And we all thought, wow, that sounds like not a bad idea. I mean, why didn't we think of that before? And then having this team all working together, once you land on an idea that you think has real promise and can work, it allows you to then very quickly evaluate these ideas and get them to a point where they can be practically implemented. So normally in Sasol, we first want to understand the theory, then we want to do something on lab scale, then on pilot scale, then do the engineering. But having a task team approach allows you to do everything in parallel, and it speeds up the process. So normally for something like this, you'd look at 2 to 3 years in Sasol to implement. We had this idea done in about 4 or 5 months, with all the piloting work completed, everything, engineering package completed, ready to go. Another example was an acrylate waste that we also produce in Sasolburg. So this is as a result of one of the polymer processes, and it's essentially, an acrylate is like a plastic, right? So we were sending it to a third-party waste provider who was blending it and using it as an alternative fuel. But then we got a shock early in 2017 when the waste provider phoned us up and said, in 2 weeks' time, we're going to stop taking your waste because of the odor concerns with blending this waste. And that was a real problem, because we had a process that had an outlet for a waste, and now we didn't have this outlet. So the consequence was, shut down this process if you don't have another sustainable alternative. So again, we had all 3 elements of that are required. We had the urgent and critical need. The goal was very clear. We had 2 weeks plus whatever storage capacity we had on site to develop a solution. And that allowed us to access almost unlimited resources whoever we wanted. If we felt that person could add value to the team, that's what we did. And again, work the process, brainstorm the ideas, and usually the idea that you initially brainstorm is not the idea that comes on at the end. It's usually these ideas breed new ideas. So in this example, we started with 38 ideas, and one could quite quickly see that we were in trouble because of the exceptionally short time frame. You would need, everything that we're talking about would need longer to implement. And then one morning, one of the really junior organic chemists came into the room, and he said he'd been thinking about this waste, and he wasn't seeing it as waste. So he was looking at it as this molecule. So in his head, he saw a molecule which none of us had seen. We had all seen there's this high CV acrylate waste with odors, but because he was an organic chemist, he was seeing this molecule. So he came the one morning and he said, well, have we thought of this oxo-Michael reaction? And I didn't even know what that was. I mean, half the engineers in the room just looked at him like he didn't know what he was talking about. And he said, well, you can take methanol and combine it with caustic, and then react that with this acrylate, and you make this ester that doesn't have an odor. And then we all stood up and said, well, Sasol makes methanol, we also make caustic, so we've got those products readily available on site, let's try it. And that same day we went into the lab, we mixed this up, we tried it, and wow, I mean, I even had a bottle of this in my car because I couldn't believe that this waste that, if you spilt a drop, you'd probably clear this room, had now transformed into something that had almost no smell. So again, we were very quickly able to work the concept. We were able to do the lab work, do the piloting work, and having the engineers in parallel, we were able to also develop a concept that could be implemented quite quickly. So am I just picking two examples that we struck it right, or does this really work, right? This is a picture of our waste footprint over the last decade. So you can see that driving this approach, looking at forcing you to look at alternatives to landfill and incineration, does in fact work. I'm not saying we're there yet. I mean, the final waste footprint, if you look at last year, we still had 500,000 tons of waste per year that we produce. So we still make a lot of waste, and the challenge is still big. And if you look at it, more than half is still hazardous. So the challenge is still there, and there's still a lot of work to be done. But we are using this approach to tackle waste management and drive innovation in this space. And we are definitely seeing the results. So just a couple of things, because this process is not an easy process or a natural process that comes to big organizations. And I think maybe if I can just share some of the things you need to watch out for when you're trying to drive this process. So the first thing, and we see it a lot at Sasol, is the bureaucrats in the room. And they are typically the people who bring the corporate language in there, and they immediately use this to stifle innovation. Where have you taken it through the gate system? Have you got this registered on the SAP system? Have you got a purchase order with 3 quotes for this? And they will find ways to slow down the process. And in my experience, I think the only way to get around this is to really have that first element where you have the strong management support, because that allows you to short circuit processes if needed. Now, I'm not saying you need to be reckless and jump straight to the solution and bypass all governance, but having management support allows you to also decide what is actually critical to enable this project and what's not. The next thing that you need to watch out for is the makeup of this task team. So again, in big organizations, you have to be very careful when you want to put this team together to innovate. You can't have people who want to stick to their job description. In these kind of environments, you want to have people who are willing to think completely outside the box, do whatever is necessary to get to an answer, and you will see at times, especially when it's not going well, it's very easy for negativity to creep in, and especially where a task seems impossible. So we had in the first example where no one else had done this before in the world, and we were having a lot of pushback from the Secunda business to take a waste stream and put it in their process. It was very difficult. But again, if you've got the right support and the right sponsorship to drive this through the organization, it can be done. And then this one, lone wolves, those are the kind of people who like to work by themselves. And they, unfortunately, doesn't work in this kind of an environment, because you want to bring ideas to the table every morning, have them robustly discussed by the team, and either decide as a team how we're going to progress this, or as a team we're going to kill this. So you don't want the kind of people who want to, I'll sit in my office and I'll think of this idea and I'll champion it myself and hold on to it and not allow anyone else to touch it. Getting proper buy-in from all the stakeholders, another very important thing. So you can't have half-hearted buy-in. If you're saying this is a priority, then everybody must make it a priority in the organization. You need, right from the driver who's picking up samples to the person who's going to run the pilot plants, everything has to be lined up, the engineering team, the commercial departments, everyone needs to feel the same pressure. So that proper buy-in from everyone has to be there. And then lastly, I think in both the examples I showed, almost all the ideas you start with are not the ideas that make it to the end. So you have to have this culture where it's okay to pick the wrong horse and get it thrown out. You can't allow people to be afraid to speak up or become attached to their idea or push something just because they feel that if their idea is not the one that makes it forward, they're going to be criticized for this. And I think that's probably one of the hardest things to drive in a corporate where you are rewarded on results. But what you have to drive is that this is a team outcome and this is where we want the team to get to. So just to end off, let me just summarize. With crises, it does bring about heightened energy levels. There's usually panic and a lot of shouting and a lot of pressure. But I mean, if there's strong leadership in an organization, this can be focused and it can be used to guide a team in the right direction. So to summarize those 3 points again, the first one, as I said, the most important thing that we found is having these diverse teams put together, forced to look at a problem and a dedicated task team. So you don't want these people who are, there's 20% of my time allocated to this. These are people who are going to hit this problem until we get an answer. The second thing is a clear and common goal. So as I said, you don't want to have something where you think that we want just something better or an incremental improvement. The team must be crystal clear in what they're aiming for. And then the last thing is the strong management support. I think this also is a critical element in that you don't ever want to get stuck in this innovation process because you missed a budget cycle and now you have to wait for money to be allocated in the next quarter, or you haven't got a signature for something and that delays you by 2 weeks. This has to move at its pace and rhythm to create that climate for innovation, and having the right management support drives that. Thank you.